Hey, it's Tim the Tutor here with Free Test Prep Online, and in this video I'm going to teach you how to use an amide as a protecting group in a Friedel-Crafts alkylation or acylation. When presented with the following synthesis, many students forget that there's a problem with doing a Friedel-Crafts directly when there's an amine on the ring. At first glance, since that NH2 is an electron donating group and an OP activator, it looks like this is going to be a simple reaction where we simply carry out a Friedel-Crafts acylation. However, the problem is that anilines cannot undergo Friedel-Crafts alkylations or acylations because the nitrogen is too basic. This causes it to form a complex with the Lewis acid, usually AlCl3, that is supposed to be used to create the electrophile. In order to add an alkyl or an acyl group to an aniline, we have to follow a three-step process. The first step is to protect the amine by converting it to an amide using a nucleophilic acyl substitution reaction. If you're not familiar with nucleophilic acyl substitution, feel free to check out my video, Carboxylic Acids and Their Derivatives. We're going to react the amine with an acid chloride. That's going to convert it to an amide. The benefit of an amide for this reaction is that the nitrogen has a lone pair that can do resonance with the oxygen on the amide. This is going to delocalize that lone pair, making the nitrogen far less basic than it was as an amine. Since it's no longer nearly as basic, it will not form a complex with the AlCl3 in the subsequent Friedel-Crafts reaction that we're going to do. This will allow the electrophile that we need to create for the EAS reaction to be formed as usual. The next step is to simply carry out the Friedel-Crafts reaction. In this case, since we're adding an acyl group, it's a Friedel-Crafts acylation. If you need a refresher on the mechanism for this reaction, feel free to check out my electrophilic aromatic substitution video. Last, we're going to convert the amide back to an amine by adding acid or base with excess water. This process is known as hydrolysis. And for this, we can simply use the hydrolysis shortcut that you can find in my one-slide guide video to hydrolysis, where we cleave the carbon-nitrogen bond and put a hydrogen back on the nitrogen. Normally, when we do the hydrolysis shortcut, we focus on the carbonyl. However, in this case, we actually wanted to focus on the benzene ring since this was a benzene synthesis. So in this case, we care that we get back our amine, and the carboxylic acid that we're going to get is actually going to be considered the byproduct in this reaction. With those three steps, we have completed our synthesis and used an amide as a protecting group for a Friedel-Crafts acylation. In the notes below, I will include links to the videos referenced previously. If you got something out of this lecture, please feel free to like this video and subscribe to this channel. If you have any questions or comments, leave a message below. And last but not least, if you want more help or want easy access to valuable organic chemistry resources for free, be sure to check out the notes underneath this video with a link to join our community.